Hello, good day, viewers. You're welcome to today's class. I remain your tutor, Aisha Bande. We have a question to solve today, which is under standardization. Under standardization, the unknown concentration of a given solution can be determined by titrating it with another solution of known molar concentration. Now, this is carried out experimentally. We have a question to solve which says A is 0.05 mole per dm cube of H2SO4. YB is sodium trioxocarbonate 4 solution. If 37.5 centimeter cube of the acid was required to neutralize 25.0 centimeter cube of trioxocarbonate, so we have to calculate the concentration of B in mole per dm cube. We're given the equation for the reaction, which is H2SO4 plus Na2CO3 as the reactant, and the product, which is Na2SO4 plus H2O plus CO2. So let's begin solving this question. But before we begin solving, there's a relation or a formula which is given as CAVA over CBVB is equals to NO over NB. So each of this term here has its meaning. Ca means concentration of acid. Va is the volume of acid over the concentration of the base times the volume of base. Na is the number of moles of acid, while Nb is the number of moles of base. We get the number of moles from the chemical reaction that has been given from the question. But before we solve, we need to check our chemical equation to ensure that it's balanced. Okay. So looking at this now, at the right hand side we have the elements we have are hydrogen, sulfur, oxygen, sodium, and carbon. Hydrogen here has a value of 2, sulfur here is 1, oxygen here is 4 plus 3 here, total of 7. Sodium is 2, while carbon is 1. That's for the reactant side. Let's go to the product side. The hydrogen here is 2, sulfur is 1, oxygen here is 1 plus 2, that is 3 plus 4, 7. Then the sodium is 2, while carbon is 1. So as you can see, both on the reactant and also the product side, all the elements are balanced. So this means we have a balanced chemical equation. So that means we can move on. Now let's bring out the parameters that has been given from the question. This is 0.05 mole per dm cube of H2SO4. And we know that H2SO4 is an acid. So what that means is that concentration of acid is 0.05 mole per dm cube. Okay? While B is sodium trioxocarbonate. Okay, now it says that if 37.5 centimeter cube of the acid, that's the volume for acid, which is 37.5 centimeter cube. Okay, was required to neutralize 25.0 centimeter cube of trioxocarbonate. Trioxocarbonate here is the base. So what this means is that the VB, that's the volume for the base here, is 25.0 centimeter cube, right? We have to calculate the concentration of B. That means we are looking for CB, that is concentration of the base, is the unknown. So now, for us to get the number of moles of acid and number of moles of base, we go to the equation to check that. We can now let's check the mole ratio. This is going to be 1 ratio 1 ratio 1 ratio 1 ratio 1. So what this means is that the acid in this case here is the H2SO4. So that means the number of moles is 1, while the base, which is the trioxocarbonate, the number of moles also is 1. So now we have all our parameters. All we need to do is substitute the parameters into the expression given. Okay, we substitute in and get the final correct answer. So here we have a Ca, which is 0.05 times Va. Sorry, viewers, this is the volume for acid. Okay, so that means our Va here is 37.5 all over. Cb is the unknown, so we have Cb times the Vb, which is 25.0 equals to Na is 1 over Nb 1. So from here, all we need to do is cross multiply. So we're going to have 0.05 times 37.5 times 1 is equals to 25.0 Cb times 1, which gives us the same. So Cb, concentration of base, is going to be 0.05 times 37.5 times 1 all over 25.0. So our Cb is equal to 0.0750 mole per dm cube. So this is the concentration of the base, and we asked to find it in mole per dm cube. So the SI unit is very important. Okay. So viewers, this is all we have today. See you in the next class as we solve more examples. I remain a tutor Aisha Bende. Bye for now. God bless you all.